Okay, we're going to be talking about the valve job on the Briggs 206 today, and just going over a few of the things involved with doing a valve job and some of the tooling that's available to do it, and what are some of the upsides and downsides to that. So we'll start off with just the basic geometry of the valve job. So on the Briggs 206 head, you're allowed two valve angles on each valve seat, which would be a 45 and a 30-degree angle. And on this head, it's kind of hard to see, but here's your 45, and this is where the valve's going to be seating. That's the sealing surface. And then much smaller, which is going to be hard to pick up with the camera, but there's a 30-degree cut right there. So the different components that go into the cylinder head that control the valve, you have your valve seat, which is the steel ring that's pressed into the head here, and that's where those angles are cut into. And then you have the bowl area of the head, the aluminum part of the head, and you have your valve guide, and that's where the valve stem goes through. So basically, when we do a valve job, we're looking to keep what they call concentricity between the valve guide and the valve seat. And we're also looking to keep perpendicularity there. So we want to have the seat to be cut at 90 degrees to the valve guide. So I have a 3D model here of a Briggs animal head in the computer, and just see if we can give you a little better representation of what's going on in the head. Let me just get this. Okay, that should work. Alright, so here's the Briggs animal head. This is a 3D model of the head. It's not perfect, but it's a good visual representation of what I'm trying to show here. So what we're going to do is, and you can see the same as in the head itself, you have your valve guide here and your valve seat and your angles here. This is the 45-degree angle. This would be your 30-degree angle right here. So what we're going to do is we're going to cut the head through the center of the intake port so that we can see all of that. Okay, so now this is the head, essentially. It would be essentially if I took this head and just sawed it right in half right there. So this is the valve guide. This is the bore for the valve guide. And up in here is your seat angles that you have. So if we look here, we could see the angles clearly. So basically you have your 45-degree angle here, which is what we're sealing on. Then you have your 30-degree angle here, and then the flat of the seat, what's left of the seat after the 30-degree cut. So we're trying to get that valve seat square to this guide. So if I draw a line through here, so if you draw an imaginary line up through the guide, which I will do here. So now you can see this black line. This is going through the center line of the guide. So we want the face of the seat, all the faces in the seat, to be 90 degrees to that. And that's where the different types of tooling come in that are going to help control that kind of geometry. The other part of the geometry that we're trying to hold when doing a valve job is going to be the concentricity. And what that means is, if I look at this head through the top, that means the distance from this bore to the valve seat bore, you want that to be the same all the way around. You don't want this hole to be off center to that angle. You don't want that angle shifted any. And that's where, the tooling that you're using on the valve seat, they use pilots that allow it to hold the concentricity. So now we'll look at some of the tooling and how it works and how it controls that geometry. So the most common kind of tooling, well, I should say the most common thing to do on a valve is going to be to lap it. This is what a lot of guys do at home. They lap the valves, and basically you're going to get a lap line. Let's see if I get that to focus. You can see this valve. This is a used valve I took out of a head. You could see that gray line going around on that 45-degree face, and that's a lap line that somebody took lapping compound, which is an abrasive compound that you would put on the face of the valve, and you would put the valve inside the head here. I'm sure a lot of you know. And you would take a suction cup on here and spin that back and forth to lap the valve in. So the problem with that is with lapping is really, the only thing we use lapping for in an engine shop is going to be to do away with any very minor imperfections in the valve seat. As this engine runs and heats up and cools down, the diameter of this valve seat is going to spring out around from the heating and cooling cycles. And that's why when you cut a valve seat on a brand new head and you go ahead and run that head in some races, you're going to start to see some leak down on the valve seat because the valve seat hasn't been seasoned yet. It's moving around from the different temperature cycles, and it's shrinking in areas and growing in areas, and generally they like to grow bigger here between the two seats, as that's the hottest part of the intake seat right there, because it's closest to the exhaust, and the intake seat will tend to leak right in this area, especially on a new head that hasn't been recut and is being run. So when you lap a valve, if this springs out, let's say 2-3 thousandths, or this seat's at around 2 to 3 thousandths, that lapping compound is meant to remove things that are maybe a thousandth. So to get 2, 3, 4 thousandths out around, to correct that with lapping, you would have to use like a very abrasive, a rough compound, and you'd be there for a long time. And also what you would end up doing is, as you lapped it, you would end up digging a groove into the valve. And a lot of times with the heavy lapping compound, because it does take up some space between the valve seat and the seat, it'll put a little groove in the 45, which is not good for airflow. And then when you wipe the lapping compound out, you may have a little space in there from where the lapping compound was. Basically, in the engine shop, when we use lapping compound, we use a very fine compound, and it's just to take out the most minor of imperfections in the valve job. So that's the first way that people, complete valve jobs, and they'll do a leak down test after they lap it, and they'll say, oh, it leaks good, and this kind of thing. And a lot of times, if you lap the hell out of it, you will get it to leak down good. But what I have noticed with heads that are lapped is, when you run them, they start leaking pretty soon after. And like I said, you also have the things of lapping grooves into the valve, which hurt airflow, so that's going to hurt the horsepower of the engine a little bit at the top RPM. The 206 doesn't go a lot of RPM. We're only going 6,000 RPM, but it will, having a little better airflow will help the engine up at the high RPM. So the second way that people cut valve seats is using a cutter like this. This is a cutter from New Way, and basically how this cutter works is it has a pilot, and what this pilot does, this pilot fits inside the valve guide, and it has a taper to it, so it tightens itself in the valve guide as you push it down. So this pilot is helping to maintain the concentricity of the valve seat, and also this pilot being pushed into the guide is parallel to the guide. It's straight to the guide. But a cutter like this New Way cutter, and you would slide this over here, and there's a hand crank tool that goes on here, and it's going to turn this cutter, and these blades, these carbide blades, are going to cut the seat. The issue with this cutter and the next one I'm going to go over, which would be grinding stones, which is how valve jobs were done for a long time. A lot of guys use these stones. I like them. I use them myself. These are basically very similar to the New Way cutter, except that instead of using carbide blades, it's using a stone. And basically this is on a holder here that has a bearing inside of it and a spring. So you put your pilot on there, and let me see if I can get this better. Zoom out. And basically that'll sit on there like that, and there's a bounce spring in there, and so you would put a motor on this. There's a motor that attaches to the top that spins it, and you would push down, and this is going to grind the seat. So basically both of these style cutters here, both of these style valve seat tools are cutting in the same manner. They're cutting with a downward force, so you're pushing down, and in this case these blades are cutting, and the stone is grinding. So the downside, these are good because they're easy to use, especially the New Way cutter. They're easy to use, and they're economical. They're not very expensive. And but the downside to this is that if you have a situation where your valve seat, where this valve seat here is not 90 degrees to your valve guide, what's going to happen is when this cutter goes on there, let's say that seat's a little bit crooked, and I'm going to exaggerate, but let's say this is going like this. As you push down, the cutter's going to have a tendency to want to flex the pilot and sit flat to whatever was there already. So what that could cause is you can get a larger 45 angle on one side than you would on the other. And even though the seat would be concentric, it wouldn't be 90 degrees to the valve guide. And that could cause some sealing issues, because when you put the valve in there, the valve is going to want to come down flat, and it's going to actually, the spring is going to actually pull the head of the valve slightly crooked to seat it, if the valve spring's strong enough. If the valve spring's not strong enough, you're going to get a little bit of leakage there, or some leakage is going to develop as time goes on there, because the valve is going to have a little less pressure in that area against the seat. The best way to cut valve seats, and this is getting into, you're going to need some kind of machinery. You can use these style cutters on, like a milling machine, like a Bridgeport, or a seat and guide machine that's made to do heads. And, that's basically how you can use them. And what this is a cutter body here that has an insert in it. And this cutter body rides on a pilot just like the others. So a pilot just rides up on this pilot here, and you would have a spring under here. And this particular one is set up right now to do a car head. I do use this large cutter body to do the animal heads and the clone heads, but I had to modify it significantly. This cutter holder here is for a car. I have a modified one that I use on the small valve heads, but they do make a smaller version of this cutter body that is made for smaller heads. At the time, I didn't realize it, so I had bought this one because I do a lot of car heads, and then I was able to modify this to be able to work. And basically, the way these have these inserts in here, and I left the car insert one in there because it's a little easier to see than the small insert. But these inserts have all the angles already built into them. So this one here has, I believe, 4 angles on it. And, the one that we would use for the animal head would have, or the Briggs 206 head would have 2 angles, a 30 and a 45. Now, they don't sell an off-the-shelf insert that I've seen with just the 30 and the 45, but so I actually just grind my own insert, or I take, one of the ones that they sell that has a 60, a 45, and a 30, and I relieve it where the 60 was, so just the 45 and the 30 is left. So basically, this cutter, it goes on the pilot, like I said, just like the other ones, with a spring here, and it has a ball drive on top. So there's a driver here that has a cup in it, and this comes down, and this cup allows, some difference between the machine and the center line of the valve guide. So it allows it to rotate here, and basically it's trying to just put pressure just to spin it. and not influence the cut. And this way it cuts true off of the valve guide, off of the pilot. So that's definitely the best type of tooling you can use for cutting, valve seats. Do you need to do that for a 206 head? These are more than sufficient. The New Way and like the Stone setup, because you don't go a lot of RPM with these engines. I mean, we're just trying to get a good seal out of them. I mean, there's not really much more you could do with that. As far as like on a high performance car head, we would add angles and things like this to help with airflow. So on these, you're trying to just get the seat concentric, get it straight, and this way you have a good sealing surface. I prefer the Stones to the New Way cutter for a couple of reasons. One, you could dress this stone. You could adjust the angle on the fixture to dress this stone at whatever angle you want. So this one right now this is a 45 stone. This is cut at a 45, and this would grind a 45 degree angle. Now, even after I cut a valve seat with a tool like this, these tools they do tend to leave just a little bit of chatter. And even the New Way cutter will leave some chatter because of the way the cutters are. And it's nice to go in with the stone and bump it with a finishing stone after, and that'll just smooth that surface out and get that surface, that 45 surface really smooth. If you have a little bit of chatter on the 30, that doesn't really matter because you're not sealing on that surface, and that back cut, that 30 degree cut there, that top cut, that's just there to, help the engine with the airflow. So basically everything that I've said about the 45 and the 30, I mean, that applies to the intake side. On the exhaust side, I usually just grind a 45. I don't put a 30. I've never seen any difference with putting the 30 in. And the other thing is with the exhaust, I mean, we're always trying to, we're trying to make the air flow better out. We're also not trying to help it flow back in. Every engine has a certain amount of reversion. And, I try not to do anything that's going to increase the airflow coming into the cylinder, where on an intake side, everything is centered around getting the air into the cylinder. So those are the things that, the difference between an exhaust seat and an intake seat. The exhaust seat on a 206, I typically don't put a 30 degree cut, and I typically go much wider with the 45 degree cut on the exhaust seat than I do with the intake seat. So the other thing to keep in mind when you're cutting with cutters like this, or any cutter really, is the more you cut away from here, the larger the diameter is going to get. And eventually, if you cut too much, you're going to get to the point where the valve is going to want to seat past the edge of the valve, past the margin of the valve. And on a normal cylinder head, what we would do if we had to go deeper, we would just go larger with the 30 degree cut to basically relieve that valve seat so that your sealing surface, your 45 sealing surface, falls into an area where you would want it, which would be more towards the edge of the valve, but not all the way to the edge. You still want a little bit above the margin of the valve. So, but on the 206, in the rules, we can only go so big with the 30 because there has to still be some amount of the flat top of the seat left. You can't cut the 30 to the aluminum. That would be considered illegal. So those are the kind of things that you have to look out for when cutting the seats, is not to cut the seat too deep where, you would have to cut the 30 too big and you would get out to this aluminum, making the head illegal. The other thing with cutting the seats deep is you're going to lose some compression because you're going to sink the valves deeper into the seats. So that's going to take away some space in this combustion chamber, which is going to affect compression. So, I mean, that's pretty much it. That's pretty much the basics of the valve job. I guess I can go over some, really the main mistakes I see guys that maybe do it at home or do it themselves is they overlap the valve, or they don't use any kind of tooling to cut the valve. If you're gonna try to build, a top contending engine, I would say at least get a new, these New Way cutters here. This is the New Way small series cutters, they call them, and they sell them in a variety of angles, and you can buy the 45 and the 30 degree cutter and the pilot for it. And I prefer to use the hand crank one. They also sell a handle to turn the cutter they sell a T handle, but I do prefer the hand crank. It has a spring built in, so you could like vary the pressure. And but using these things does take a bit of feel, because you can influence that cut by moving the handle one way or the other, and it's going to cut more on one side than the other. So that's another downside to this, is you have to have a good feel to cut with these. The other downside to this is we can't control. It's very hard to control the depth of the cut. I mean, you're basically going to have to cut a little away, look at it, and see how deep you want to go. Whereas if we were using a valve machine, or let's say a Bridgeport or something like that, that had a DRO, a digital readout, we can accurately measure the depth that we're going, and you could even calculate, with the angle and how far you're going, how much bigger that seat's going to get on the diameter. So that's something that, we do here in the engine shop when we use our seat and guide machine. I have a Quickway seat and guide machine, and it has a DRO on it, and I know exactly the depth that I want to go, and it's very easy to control. Same with the stones. It's hard to control the depth. I mean, these are things, it takes a long time to get good at using. Also with the stones, when you put the motor on the top, you could easily hold the motor off to an angle and create more pressure on one side of the stone than the other. And, most of the pilots you're going to use are just made out of what they call high-speed steel, so they have a bit of flex to them. Now, like a pilot I would use for the cutter body that I showed, that's made of carbide, so that has almost no flex to it, and that's going to keep the integrity of the cut without having any kind of deflection away from the valve seat. So that's like the common things that I see at home people do, whether they're lapping, they overlap the valve, or if they're using a new way cutter or a set of stones, they don't, get straight to the seat, or they influence the cut in one direction or another, and now the seat is crooked. So that's basically the main things that I see. Also, the other thing is cutting the seats too deep, and not really getting a good sealing surface because you're past the edge of the valve. I've seen that. Or, cutting the 30-degree too deep and the 45 too deep, where now the head would be illegal. It's not going to make it through tech. So those are the common things that I see, in the engines that I do, that guys do at home, or use, this type of tooling, that these are the issues that I see pop up with that kind of stuff. So again, I mean, lapping the valves, you want to use a fine compound, and it's just to take away any kind of imperfection. I mean, most of the valve jobs that we do here, we don't lap them because, they come out perfect, and they're going to seal perfect, and there's not really a reason to lap them. Especially when you bump it with the stone after you've cut it with a cutter. That really gives it a nice surface finish in there, and we regrind the valves to have a really nice surface finish, and so everything seals really good. Now, every once in a while, you'll get one that has a bit of leakage, and then I'll go in there with some fine compound and lap that in. And when you're lapping something like that, the valve will essentially, it'll lap and it'll lock up very soon after. You're not going to make many strokes with the lapping, or many back and forth motions with the lapping, before the valve, what we call, locks up. So basically, you would have your valve in there and you'd be lapping it, and then all of a sudden the suction cup would slip, because now that valve is locked into that. It's basically like a taper fit on a flywheel. You have a 45 and a 45 taper, and that's locking itself into place. So, that would be the extent of the lapping that we do here. I mean, if the seat is worse than just what a little bit of lapping would take care of, we would then go ahead and readdress that valve seat and recut it, which is what I would suggest somebody at home using these do, and try to hold the handle much straighter, and not try to influence that cut. So, I mean, this is a little bit of in-depth information. It's a little more technical here when I'm going over here, but the guys that, there's a lot of people that are building their own engines, or getting into being, 206 engine builders, or whatever you want to call it. And I see a lot of guys post videos online and stuff, and basically, this is my opinion of how to do it the right way, and my opinion that I have of how to do it that way, and all the things that I've said is what I've come up with over the years of just being a machinist and working on engines and things like that. And some of my opinions change over the years as you evolve as an engine builder, or as a machinist or anything. And but as of right now, that's the information that I feel is important to doing a valve job. So I'll leave you with that, and that's pretty much it. And I hope I could help some of you do a little better job on this stuff, and give you some information on the tooling there, and maybe you can decide for yourself if you want to use some of these different tools, or investigate stepping up to something a little more complicated with the tooling, like the cutter body, or something like that. So thank you.